Find the elevation at point F in feet. In this problem, points A through F are positioned along an open traverse. Survey data is provided, which includes the backsite readings, the foresight readings, and the elevation at point A. All length values in the data table are in units of feet. The problem asks to find the elevation at point F. In this analysis, we'll begin with point A, because we were given its elevation value. From here, we can relate the elevation between two consecutive points, A and B, using the backsite and foresight measurements. The column labeled HI represents the height of the instrument, or more precisely, the elevation of the line of sight based on a vertical datum, or benchmark. Before we can find the elevation at point F, we first have to find the elevation at point B, and then we'll work our way down to point F, one point at a time. If we take a closer look at points A and B, we can better understand the leveling procedure. From the problem statement, we know the elevation at point A equals 862.09 feet. If we place the measuring rod at point A and take a level reading from the instrument to the rod, the backsite distance for point A is the vertical length from the ground up to the sighted location on the rod. As mentioned before, the height of the instrument AB is the vertical distance between the datum and the elevation of the line of sight. Now we can compute the height of instrument AB as the elevation at point A plus the backsite reading at point A, which equals 867.24 feet. Next, the rod man sets the rod vertically at point B, and the instrument man takes another level shot at the rod. This reading on the rod represents the foresight elevation, which in this case is for point B, and for this example equals 2.64 feet. And the elevation at point B equals the vertical distance from the datum to point B, which equals the height of the instrument minus the foresight reading. After plugging in the known values, the elevation at point B equals 864.60 feet. Looking over our equations, the elevation at point B equals the height of the instrument minus the foresight reading. But previously, we already solved for the height of the instrument as the elevation at point A plus the backsite reading to point A. Substituting in the height of the instrument, we can equate the elevation of point B to the elevation at point A plus the backsite to point A minus the foresight to point B. We can use this equation to find the elevation at point C by knowing the elevation at point B and the backsite to point B and the foresight to point C. The elevation at point C equals 867.09 feet. We'll continue to use this equation to solve for the elevation at points D, E, and F. The elevation at point D equals the elevation at point C plus the backside of point C minus the foresight at point D, which equals 873.09 feet. The elevation for point E is calculated the same way and equals 878.69 feet. And finally, the elevation at point F equals 874.38 feet. When reviewing the possible solutions, the answer is C.